Hello friends, in today's video we are going to discuss about function. So first of all, what is a function? A function is a mapping that assigns to each point of some domain A unique value that resides in some codomain B. It's denoted by f A to B. Now let us see some examples. Now this is a function because here each element of A is corresponding to unique element of B. But this is not a function because here one element of A is corresponding to two elements of B. So this is not a function. Now see, there is a formula to find the number of functions which is equals to n to the power m, where m is the cardinality of A and n is the cardinality of B. Now let us see what is 1 function. 1 function is also known as injective function. If a function has the property that no value of y appears as the second coordinate of more than one ordered pair in f, then f is said to be injective or 1. That is, distinct element of range corresponds to distinct element of domain. Now let us see some examples. Here this one is a 1 function and this is not a 1 function because here each element of A should correspond to a unique element of B. Like it's see, two elements means this one. If this is A, B, C, D and this is 1, 2, 3, then here A and B both are corresponding to 1. So this is not 1 according to its definition. Fine. Now let us see the formula for finding the number of 1 functions. Total number of 1 functions can be found out using this formula, that is npm, which is n factorial by n minus m factorial, where the cardinality of A is less than equals to the cardinality of B. Here m is the cardinality of A and n is the cardinality of B. If the cardinality of A is greater than that of B, then the number of 1 functions is equals to 0. Now let us see onto function. Onto function is also known as surjective function. A function f from A to B is onto if every element of B has a pre-image in A. That is, if its range is equals to codomain. For example, this one is a onto mapping, a onto function, okay? But this one is not an onto function. Why? Because here we can see that its range is not equals to the codomain. Fine, its codomain is A, B, C, D, but its range is only A, B, D. Its range is not including C. Fine, so just because range is not equals to codomain, so it's not onto. Now there is a formula to find the number of onto functions, which is this one, summation r equals to 1 to n minus 1 to the power n minus r, n c r to the power m for n less than equals to m. And if n is greater than m, then that is equals to 0, where n is the cardinality of B and m is of A. Fine. So the condition for applying this formula is this, that the cardinality of B should be less than equals to the cardinality of A. Now let us see some questions based upon 1 and onto function. We have to tick on the correct option. Now the function f of x equals to ex, where x belongs to R, is which of the option is going to be correct? Let us see. So f of x equals to yx can be written as y equals to ex, and its graph is going to be somewhat like this. Fine, this is the graph of y equals to ex. Now for checking 1 apart from the definition of 1 function, there is one more condition through which we can check whether a function is 1 or not, and that is we are going to draw a line parallel to x-axis, and if that line cuts the graph at only one point, then that's going to be 1 1, otherwise not. So let us draw a line parallel to x-axis. Fine, so this is a line x dash. So as we can see, this is cutting the graph at only one point, so this is 1 1. It's proof that this is 1 1. Now for checking whether this function is onto or not, we are going to write first its range, which is equals to 0 to infinity. Okay, and its codomain is whole real number r. Fine, the whole real number r, that is the real number consists of all the positive and negative values, but here the range is consisting of only the positive real numbers. Fine, so you can see that the range is not equals to codomain, therefore it's not onto. Okay, so let us see another question based upon 1 1 and onto function. A mapping f from r to r, which is defined as fx equals to cos x, where x belongs to r is. Now let us draw the graph of y equals to cos x. Its graph looks somewhat like this. Now we can see that for different values of x, we are having same value of y. Like for x equals to pi by 2, we have cos x equal to 0. Similarly, for x equal to minus pi by 2 also we are having cos x equal to 0. So this is not 1 1. Fine. So this is not 1 1. By another method also we can check whether it's 1 1 or not. Like when we draw a line parallel to x-axis, then we will see that it will cut the graph at more than one point. Fine, it will cut the graph at more than one point, so this is not 1 1. That is another method. Now for checking whether it's onto or not, for checking onto function, we know that its codomain is r and its range is minus 1 to 1. This is the range now, minus 1 to 1, which is not equals to the codomain. As range is not equals to codomain, so it is not onto. Okay, so this is, so its answer is neither 1 1 nor onto. Over.